Hi Year 12. In this video we're going to look at volumetric analysis. What is volumetric analysis? Well, essentially it's taking one solution of a known concentration, in this case 2.00 mole per litre hydrochloric acid, and using it to find the concentration of an unknown solution. It's sodium hydroxide, but I'm not sure what its concentration is. So to do this I need to do a practical experiment. Here's the scenario. 2.00 mole per litre hydrochloric acid was reacted with sodium hydroxide until neutralized. A 10 ml aliquot of hydrochloric acid was used. An aliquot is simply a portion of a whole. So if I had a whole apple, a slice of the apple would be one aliquot of the apple. I have a balanced chemical equation. Hydrochloric acid plus sodium hydroxide gives me sodium chloride plus water. It's all balanced, same type and number of atoms on each side of the arrow. And the question is, what is the concentration of the sodium hydroxide? To figure that out, I need to do a practical. The practical I'm going to do with you today is fairly rough, and I'm just going to use it to show you the ideas behind volumetric analysis. So I've got here a beaker with a magnetic stirring flea on a magnetic stirrer. So that will automatically stir for me. So what I'm going to do is I'm going to take 10 mils of hydrochloric acid, just like my scenario required of me. And I'm just doing that by syringe. So there's 10 mils of hydrochloric acid. Now if I just go and pour some sodium hydroxide in there and keep looking to see when the experiment's going to be finished, I'm going to be waiting for a very long time, because without an indicator I wouldn't see anything. So I'm going to add some phenolphthalein as my indicator. Phenolphthalein is colourless when in acid and pink when in base. So I put 4 drops of phenolphthalein in there. As you can see, it stayed colourless because I've started with hydrochloric acid in my beaker. What I'm going to do now, very carefully, is add drop by drop sodium hydroxide until I see a colour change. When my phenolphthalein goes from colourless to pink, that means my solution has changed from being acidic to alkaline or basic. That will mean that every bit of my hydrochloric acid has been reacted with, it's been neutralised, and the first drop that makes it go pink means my solution is then alkaline. There's no more hydrochloric acid left, the pH has gone from acidic to alkaline. So I'm going to add sodium hydroxide carefully, drop by drop, and I'm looking for the first permanent change to pink. So I've got 10 mils in my syringe there, and in it goes. Now just while we're waiting for the colour change, normally we would use a process called titration for this, using very precise glassware and very precise technique. I'll teach you that when you come back to school, and for the purposes of this video, this will be sufficient to teach the chemistry. So that was 10 mils in there, still no change, so I still haven't neutralised all of the acid. So I'm going to add some more. I've taken another 10 mil sample, going drop by drop. You can see there's a pink colour that's there temporarily and then it fades away. I'm looking for a first permanent pink colour. So I'm going to slow down my dropping rate. Okay, it's there. And as it mixes, it slowly fades out again. Let's go another drop. Okay, that pink colour looks like it's going to hang around. And I've used 15.4 mils of sodium hydroxide to get to that point. Let's carry on with our calculation. 15.4 mils of sodium hydroxide was used to neutralize completely my 10 mils of hydrochloric acid. Okay, so let's work through the calculation process. There's my balanced chemical equation, and I've written my triangle for concentration, number of moles and volume in the top corner there, just to be a helpful reminder for us. So What was the information we were given at the start of our practical? We were told the concentration of our hydrochloric acid was 2.00 mole per litre. We were told the volume we were to use in our reaction was 10 mils. And you should remember that volume is always recorded in litres. So I've converted that into litres, 10 over 1,000 litres. The conversion from mils to litres again is dividing by 1,000. If I have a concentration and a volume of the same solution, I can work out the number of moles of hydrochloric acid in that solution. So, number of moles equals concentration times volume, times my concentration of 2 mole per litre, times the volume of 10 over 1,000 litres, gives me 0.02 mole. So that's the number of mole of hydrochloric acid that I put into my beaker. I then added my phenolphthalein and started the reaction with sodium hydroxide. Now I know that I added the exact right amount of sodium hydroxide to react completely with the hydrochloric acid. So my number of moles, every mole of hydrochloric acid I put in there will have reacted completely with sodium hydroxide. And we can see here from the equation that every 1 mole of hydrochloric acid will have reacted with 1 mole of sodium hydroxide. So my 0.02 mole of hydrochloric acid that I put in at the start will have reacted with exactly the same amount of hydrochloric acid, which is 0.02 mole. So sodium hydroxide and hydrochloric acid number of moles are equal, and that's because we have a 1-to-1 ratio in our balanced chemical equation. So now I have the number of moles of sodium hydroxide. What volume of sodium hydroxide did I use? It was 15.4 mil. Again, a volume has to be converted into litres. So it's 15.4 over 1,000 litres. If I have the number of moles of sodium hydroxide that I used and the volume that that sodium hydroxide was in, I can work out its concentration by going number of moles divided by volume. My number of moles was 0.02. My volume was 15.4 over 1,000. So that equals 0.02 divided by 15.4 over 1,000. 1.30 to 3 significant figures, mole per litre. So that's the process of volumetric analysis, and that's how to work through a calculation to find the concentration of an unknown solution from the concentration of a known solution.